Good morning, dear students. In this video, we are going to see about uh, the main part of the second unit, that is Gauss-Seidel method of load flow studies. So, this will give you how to solve the problem using Gauss-Seidel method. So, kindly watch the video. This flowchart and procedure is important one. It may definitely 70% of chances for this to be asked in your university exam. Thank you.
This video, we are going to explain the Gauss-Seidel load flow algorithm with flowchart. Gauss-Seidel load flow method is an iterative numerical technique used to solve nonlinear algebraic equation. Gauss-Seidel power flow equation. Let's consider a n-bus system. Here, especially consider the middle bus. That bus name is I. In case of ith bus, the current I is equal to, according to Ohm's law formula, I is equal to V divided by Z. 1 by Z is Y. Expand this for all buses. I is equal to Y1 V1 plus Y2 V2. Middle bus YI VI, in the end bus YIN VN. This formula can be expressed in summation form. Here, first bus to I minus 1th bus, that is the previous bus of the ith bus. Then next bus, I plus 1th bus to last bus, that is n bus. Here, first bus to I minus 1 bus, Yij into Vj. Then write the middle bus separately. Then I plus 1 bus to n bus. I plus 1 bus to nth bus. The formula becomes like this. Complex power is equated with apparent power. The complex power Pi minus JQi is equal to Vi star into Ii. From this equation, calculate Ii in left side, then cross multiply the VI term. We get Ii is equal to Pi minus JQi divided by Vi star. This is the conjugate of the voltage. Now, this equation is Ii. This equation also Ii. Equating equations A and B. You get this one. Then take Yii into Vi term in left hand side. The remaining terms are in right hand side. Therefore, the equation is Yii into Vi is equal to this term, then minus of this term, then minus of this term. Then calculate Vi so that you cross multiply Yii in right hand side. Therefore, 1 divided by Yi is equal to Pi minus JQi divided by Vi star minus summation j is equal to 1 to I minus 1 Yij Vj minus summation j is equal to I plus 1 to n Yij Vj. Here in this equation, for iterative purpose, Vi is the new term, that is Vi new. Then Pi and Qi values are specified value, that is given in the problem. Then Vi star is the old value, the initial value. Then Vj, this Vj is the new value. Then Vj, this new j is the old value. This formula is called Gauss-Seidel load flow equation. Now let's see the algorithm with steps for Gauss-Seidel method. This is a iterative method, so we can calculate this problem by using computers. Usually, in the computer, the programs are start by using the start button. The first step is start the program. Then second step, read line data, bus data, tolerance epsilon, and the acceleration factor alpha. What is line data? The line data may be the bus impedances value, the line charging admittance value, or the line admittance values are given. Then bus data. The bus data, the buses are PV bus, then PQ bus. PV bus means real power and magnitude of voltages are specified. The load bus means the real power and reactive power values are mentioned. Then tolerance. The tolerance value is plus or minus 5% for normal deviation. In case of maximum deviation, this may taken as plus or minus 10%. Then this is the acceleration factor. The acceleration factor for fast convergence or reduced number of iterations, the acceleration factor is required. Bus voltage computed at each iteration is multiplied by this acceleration factor. This value is more than unity. The range of this factor is normally 1.3 to 1.7. For this range is satisfactory for typical systems. This is the acceleration factor. Then go to step number 3. The third step, form a Y-bus matrix. These steps are discussed previously. Y-bus matrix are formed by inspection method or LU factorization method. Then next, initialize bus voltages. Here, in case of generator bus, the magnitude of voltage is specified for all iteration. The load angle is 0 for initial iteration. First iteration is assume the load angle is 0. Then second iteration onwards, the load angle, that is the phase angle only changes. Then Vk is equal to, that is the load buses. In case of load buses, the magnitude of voltage is taken as 1, then phase angle of voltage is taken as 0 for the first iteration. The second iteration onwards, this voltage value is changes. Now go to the next step, set the iteration count. Now before going to iteration, identify the data, calculate Y bus and initialize bus voltages, then go to the first iteration, that is iteration number 1. Then the first iteration also go the first bus, that is bus number 1. Look at the first bus. Usually the first bus is the slack bus or reference bus. In case of reference bus, the magnitude of voltage and the phase angle of the voltage are not changed for any iteration. So we are going to the next bus. They increase the bus number 1 by first bus by 1. That is I is equal to I plus 1. Then the next bus, the bus may be referred to generator bus. Thus, I refer to generator bus. The magnitude of voltage is specified value. That value is not changed. Only calculate the load angle of voltage. Phase angle of the voltage will be changed. In case of generator bus, the first of all calculate the reactive power. The reactive power may calculate by using this formula minus imaginary part of VA star summation J is equal to 1 to N Yij Vj. Using this formula, calculate the reactive power. Because in case of generator bus, the reactive power limits are specified. The reactive power value must be within the limit. Then only the bus sets the load bus. For that, you check the Q limit. Check for Q limit. The Q limit, the calculated value is less than our specified Q value. Then we assign the generated reactive power. Assign the reactive power of the ith bus is equal to the minimum value. The calculated QI value is maximum of the specified value. Assign the reactive power value is equal to the maximum value. Within the limit, the value is equal to calculated value. If any load reactive power may given, subtract this value. This calculation is very important for generator bus. To satisfy this condition, that is the calculated value is within the specified bus, we treat this bus as the generator bus for entire iteration. Otherwise, a bus is treated as the load bus. Suppose this bus, the second bus is not a generator bus, means the no means goes to directly go to this step. No, directly go to this step. The generator bus also goes to this step. This step is step number 10. That is compute the VA new value. This is the Gauss-Seidel iterative formula. We use this formula, calculate the voltage, new voltage for that iteration. You calculate this value, substitute all the values, calculate the value. This magnitude, the phase angles are calculated. In case of generator bus, the magnitude value is specified value. Suppose you calculate by using this formula, you get one magnitude, but not take that magnitude. Only take the phase angle. Only take the angle. Then angle substitute here. We specify only take the angle. Angle only calculated value for generator bus. The magnitude of voltage is specified. That is the given value. But in case of load bus, that is no. But in case of load bus, the magnitude and the phase angle are calculated value. The magnitude and the phase angle are the calculated value. Then next go to the next step. Is I less than n, that is the number of buses is less than n, then next go to the next bus. That is then again repeat, increase the bus by 1, then check the next bus is the generator bus or load bus. The generator bus means calculate the reactive power, then the reactive check for Q limit violation, then calculate the voltage angle. For load bus means directly calculate the voltage and the phase angle. Repeat these steps until you satisfy this condition. Beyond this condition, I is greater than n, I is yes, then go to this step. Here we check the tolerance value. That is VA new, that is a current iteration value, VA old, that is previous iteration value. The difference between these two value is less than or equal to our tolerance. We already set the tolerance value. Usually this value is plus or minus 5% of this voltage. That satisfies this condition for all buses. You calculate the line flow, total line losses, reactive power generator, etc. Otherwise not satisfied, you go to this step and multiply this value with the acceleration factor for quick convergence for all buses. Then again go to the next iteration, increasing the iteration by 1, then go to here, then increasing the iteration from the bus. First bus is a slack bus, then second bus also. Repeat these steps. Then complete all these steps, calculate all line flows, total line losses, reactive power generated of PV buses, slack bus powers by using this formula. The slack bus formula PA plus JQI, that is equal to VA star summation J is equal to 1 to N OIJ VJ. Then line flows formula SIJ is equal to PIJ plus J into QIJ. That is equal to VA into VA star minus VJ star into OIJ series. This is the OIJ series is the direct line admittance. Is directly given in the problem. The line data, this is obtained from the line data plus VA star into VA using this formula. Then line losses, real power loss, Pij plus Pji. Then reactive power loss Qij plus Qji. Then finally print or write all the results. Then stop the iteration. The flow chart is lengthy, so I split this flow chart into two. Now let's see the flow chart in a single page. The advantages of Gauss-Seidel method: it's a simple method, memory required is less, useful for small size system. It has some disadvantages. It requires large number of iterations to reach convergence, not suitable for very large systems. Convergence time increases with size of the systems. The size of the system increases, the time of convergence also increases. Suppose the system is very small, the computer memory also small, means we use this Gauss-Seidel method. Next video we will discuss.
So this is the procedure for Gauss-Seidel method. In the next video, we will discuss about a problem on Gauss-Seidel method. Thank you.